Now let's look at this projectile motion problem. A ball is thrown vertically upwards from the ground level with an initial velocity of 30 meters per second. Exactly 1.01 seconds later, a second ball is thrown downwards from the top of a 60-meter tall building with an initial velocity of 10 meters per second. Find the height above the ground at which the two balls pass each other. So to solve a problem like this, it's recommended that you first draw a diagram. So now let's draw a nice diagram. So let's say this is basically our ground. So the first ball is just being projected upwards right there. We'll call this ball A. So ball A will be projected upwards we are going to choose upwards as our positive. Okay, so it's important to choose your direction. So upwards will be positive, meaning downwards is negative. So we'll have our acceleration as negative 9.8 then. 9.8 meters per second, since it's downwards. So whenever an object is in free fall, the acceleration is 9.8 vertically downwards. So what's the velocity of A? It is 30 meters per second. So since it's upwards, there's going to be positive 30 meters per second. What else do we know? Okay, so the initial displacement of A is basically 0 since it's on the ground, and we'll take the time for A as t. All right, now let's look at B. So this is B. So B is being projected downwards. First things first, what's the initial velocity of B? It is negative 10 meters per second. Why is it negative 10? Because it is being projected downwards. So that's negative velocity. And B is being projected exactly 1.01 seconds after A. So if A, right, was projected, let's say, remember we want to find where these two balls are going to meet each other. So if it took A about just a random guess here, let's say it took A 7 seconds to reach B, right? So let's say they pass each other right there, and it took A 7 seconds to get to that point. Then it means it will take B 7 seconds minus 1.01. Okay, so which means whatever time it takes A to reach that point, it will take B basically 1.01 seconds less. So that's why time for B will be t, which is A, basically the time for A, t minus 0.1.01. So it's okay to just give ourselves a rough estimate as to where the balls are going to meet. So let's just say maybe somewhere there. Let's say they meet right there. Okay, now we will label this height right there, which will be basically how high A goes. In other words, it's the displacement of A, that will be the height. Now B will travel from where it's dropped to this point, and remember B is being dropped from a height of 60 meters. So this means this right there will be 60 minus h. Now that will be the displacement of B. Okay, so now we have everything on A, we have everything on B. we can go ahead and form our two equations since we have two unknowns, which is t and h. So now, considering ball A, if we just consider ball A, the equation that we're going to use here, the equations of motion, we have four of them, right? We will use this one since we are interested in time, displacement, and we are given initial velocity and we know the acceleration. So we want an equation that involves initial velocity, acceleration, time, and displacement. And this is the equation that involves those four. So initial velocity times time plus 1 over 2 acceleration time squared. Okay, so that's the equation that we are going to be using. Now we're going to substitute our values for A. Now we'll substitute the unknowns as well. So the displacement of A will be h. Basically it will be h since it's going to move this height. So h equals initial velocity 30, and then the time it takes A to get there is just t, and then plus 1 over, let's make that a lot clearer, 1 over 2 negative 9,8 is the acceleration, and then t squared. Now we're just going to rearrange this and just make it a lot neater. 30t minus 4,9, because we multiply this half with the negative 9,8, then we have the t squared, and let's just write it with descending powers. Negative 4,9 t squared plus 30t. Now that will be our first equation. Now we are going to substitute our values for the second part B on the exact same equation there to formulate our second equation. Now the displacement there is 60 minus h, but now remember ball B is going downwards, so which means it's negative displacement. So this is how you look at it. Now we chose up to be positive. Since up is positive, then it means if you're starting from some height or from any level, could be the ground level, and you end up above the ground, then it means you have positive displacement. But if you start at some height, right, and then you drop down below the level at which you started, then you have negative displacement because you're below where you started. Okay, just take into account that this is when you choose up as positive. If you choose down as positive, then the reverse will be true. Okay, so now this is our displacement, but it has to be negative. So it's going to be negative, and then it's going to be the 60 minus h. That's our displacement equals, so that's why I was subbing in for the displacement there, equals to initial velocity. Initial velocity for B is negative 10, and then remember the time for B is basically 1,01 seconds slower, or should I say less. Yeah, it's 1,01 seconds less than of A. Minus 1,01, and that was t plus 1 over 2, and then negative 9,8, and then the t squared, um, 1,01 squared. And then now we just have to simplify this, just make it look cleaner so we can start solving for h and t. So here we just FOIL out the negative. So negative 60 plus h equals to negative 10t and plus 1 comma 0. Sorry, I don't know why I'm saying it's 1 comma 01, because it's just going to be the negative 10 times 1 comma 01, which gives us 10 comma 1. Now I'm going to multiply this half with the negative 9 comma 8, which will give me negative 4 comma 9, and then I'm just going to deal with that squared, which basically from maths we know the shortcut will be you square the t, then you multiply these two and double it, so which give you negative 2 comma 02 t, and then you square the 1 comma 01, which will give you positive 1 comma 02. Okay, and then now we will take this negative 60 to the other side and we'll also multiply that. So h equals negative 10 plus, sorry, negative 10t. Now I'll go ahead and add that 60. It comes to the other side, becomes positive. I'll go ahead and add it to the 10.1, which becomes plus 70.1 minus, and then it's going to be 4.9 t squared, and then we'll multiply the 4 comma 9 with the 1 comma with the 2 comma 02, should give us 9 comma 898. So let me just write it as 9 comma 9 t, and then we'll multiply the 4 comma 9 with 1 comma 02, which gives us 4,998, which we'll just write it as 5. So minus 5. So we still have more like terms. We can add that, and we can also add these. So let's go ahead and do that. So just write that over there, 4,9 t squared, and then basically 9,9t minus 10t be 0,1. So minus 0,1 t, and then it's going to be the 70.1 minus 5, which will basically give us 55.1. Sorry, 65.1, 55, 65.1. So yeah, everything seems fine. Just checking if I didn't make any errors. Everything seems fine. So now that would be our second equation. So now what I will do is I'll just equate 1 and 2, since I have h is equal to all of that expression in terms of t. And then I have h is equals to this expression as well. So therefore these two must be equal to each other. So 1 is equal to 2. So negative 4,9 t squared plus 30t is equals to negative 4,9 t squared minus 0,1 t plus 65.1. Now you basically combine your like terms, so this will basically subtract each other, give you 0. So let's bring the 0,1 to the left and add it to the 30. So that would give us, so 30t plus 0.1t will give us 30.1t. Then on the right we'll just have the 65.1, and then we are going to divide 65.1 by the 30, which will give us 2.16 seconds. And then now we can use this to find the height. So let's use the most simple equation from the two. This one is a trinomial. It's a bit busy, this one. Yeah, this one has two terms, so we can use that one. So negative 4.9 t squared plus 30t. So we just substitute t to get h. Okay, so negative 4.9 times 2.16 squared plus 30 times 2.16, so we get the height to be 41.96 meters. Now remember, the h is actually the displacement of A, which is basically the height above the ground, which answers our question, since we wanted to know at what height above the ground will these two pass each other. So that is how you approach a question like this.